Good morning, everyone. This is an introduction to artificial intelligence that is denoted by AI. So, what is artificial intelligence? Artificial intelligence is defined as putting intelligence into a machine or programming a machine so that it's able to think pretty much like a human can do. Now, how do we do this? We use complex algorithms, you use maths and statistics to be able to make a machine intelligent, more or less like a human. Now, what are the criteria to make a machine intelligent or artificially intelligent? Number one, it should be able to react to new situations. And that's what we call generalized learning. That is, it should be able to adapt to any new situation it faces. Differences in temperature, a change in pressure. It should be able to act to those, take these new input and react accordingly. It should not crash if something different happens in the environment. Number two, it should be able to reason and make decisions. That is, if it comes across different paths that it should choose to take one of those, it should reason which one is better to take and which one is going to minimize the risk of something that is happening. So there has to be some risk analysis here. Which one is better in terms of time, in terms of final output, and then take a decision based on that. It should be able to problem solve. Problem solving is essential here, and based on a problem that it faces, it should be able to just digest all the input and act accordingly, take an action. It should be autonomous. That is, it should be able to take an action independent of the human intervention. So it should be autonomous. There has to be some autonomy here for the machine to be called artificially intelligent. Now, there is a quick search here that we would like you to take. Can you take a few seconds to search for who was the first person to coin the term AI, and when did he publish that? When did he publish the term AI, artificial intelligence? I'll give you a few seconds to do your search and give an answer. So the first person who coined the term AI was John McAfee. I wish that you got the right answer. And it was in 1956 when he published that in a conference. Now, there are so many AI applications that we use and which are available around us. Some of them are, you can see here that face recognition in phones is one of them, that your phone is able to recognize your face, even if you're wearing sunglasses, for example, even if you are wearing a mask. This is a kind of artificial intelligence. Also tagging friends in some social media applications, that the application is able to know that this is specific a friend and it tags them. Sometimes there are some applications which would group people based on the photos. So it knows that this person is, for example, you, and it puts all of your photos under this group. It knows that this person is another person, for example, let's say your brother. It takes all your brother's photos and put them under that group or album. So this is also a kind of artificial intelligence. We've got also Siri or Alexa. This is a kind of speech recognition. So when you ask Siri a question, it is able to understand your speech. It converts your speech into commands, and then it understands them and then give you a reaction, gives you an answer. It's able also to process your natural language. So there is here some natural language recognition. Whatever accent that you're using, it is able to understand it and then react to that as well. There are other kind of recognitions other than speech recognition. There is text recognition. So for example, if you are writing a letter and you want to digitize that, there are some applications which could take your handwriting and then convert it into a digitized document with all the letters separated. Okay, so it's not only a scanned document, but like it recognizes that these letters are A and B and C. It converts them into digitized A, B, and C. So this is text recognition. Something else is Netflix. So when you're, for example, searching Netflix, you can see that it is recommending some movies for you based on the history of watching, based on your location. So this is also some artificial intelligence in application. Something else which is close to Netflix, we've got Spotify for music. It recommends some music for you. We've got also on YouTube, if you're watching some certain types of movies or video clips, it recommends some more videos for you based on what you watched and based on your history. We've got other types also. Can you see here AlphaGo? There is a robot who is playing against a human being. It is a game that is called Go, and in this case, a robot can beat a human being. Okay, can play against them, and there are other more like applications of those kinds of things that we can see in games. So we've got a game, a robot, or an application where you can play chess against. You've got XO and other games as well. So there is some artificial intelligence applied here. Social feeds, when you go to Instagram, for example, and you browse some posts, you like some posts, you comment on some posts. Next time you're going to say in your social feed, there are some posts which are related to what you've been browsing. And you would say, are they spying on me or what? No, it's just they're taking your history of likes and comments and making some suggestions or recommendations by putting this into your social feed so you can have a look at them. Spam, filtering your emails, taking the spam away based on some algorithms. It's checking the addresses, checking some certain words, etc. So there is some artificial intelligence in here as well. Healthcare, you can see that there are some applications which are able to detect based on a scan without a doctor intervention that there is a cancerous cell, for example, which exists in this certain area by just checking all the pixels of the scan. So this is also an artificial intelligence application that is used in healthcare. Now, coming to the main classifications of AI, we've got two classes. We've got strong AI and we've got weak AI. Strong AI, we can also call it general intelligence. And just from the name, it's an artificial intelligence system with generalized human cognitive abilities. That is, it is able to work on a task which is unfamiliar to it, pretty much like a human. It has enough intelligence to find the solution. And an example is a self-driving car. For self-driving cars, which are fully generalized self-driving cars, where they can go from a place to another place without human intervention. If they are, for example, able to cross borders, when they go to checkpoints, they are able to stop, present, for example, digital passports or identity cards, be able to communicate verbally, like understand the speech, and based on what they hear, they are able to go ahead and give an answer to that. So this is a speech recognition. They're able to, when there are some obstacles in the street, they're able to not go beyond these. They're able to understand traffic lights and much more generalized. We're far actually from getting there. We've got self-driving cars, but so far we didn't get to the point where we have like this as a general intelligence. These kind of cars usually work within certain circumstances and certain environments, and they're not generalized. So self-driving cars, which are in the future, okay, maybe we're gonna get there at some point. This is called a general intelligence or strong AI. We're still not getting there, but hopefully maybe one day. On the other side, we've got weak AI that is called also narrow AI. And this is designed for a particular task, pretty much like Siri. It's designed to answer specific questions. We've got computer games, for example, AlphaGo, which can play the game Go, cannot play chess. It specifies it's weak AI or narrow AI. Applications which are trained to detect some cancerous cells, they can detect some cancerous cells, but they cannot do something else. So this is again narrow or weak AI. Now let's talk about some terminologies that come across when we talk about artificial intelligence. Now artificial intelligence is the big picture. We know now that artificial intelligence, for a machine to be artificially intelligent, this machine has to be able to adapt to new situations, be able to reason and take a decision, be able to problem solve, and take an action based on that. Autonomous, it can do things without human intervention. Now, a subset of artificial intelligence is what we call machine learning. And you can see from the name here, we want the machine to learn, pretty much like a human's. If a human has some information, and this person comes across a new situation, this person is going to process his prior knowledge and information to be able to adapt or solve a certain problem that he comes across. So he's learning based on what he had or she had, and based on what is given in the new environment. So machine learning works pretty much the same thing. It's based on feeding the computer with as much data as we can. And based on this data, the machine is going to learn and act whenever it's given an input. All right, so the more information, the more data that we feed it with, the more accurate is our final result out of this machine. An example of machine learning is that imagine that we make a program or an algorithm and we feed it with data. Let's say it's about coins, the weight of coins. So we tell it that, for example, 100 fels, it would weigh 4 grams. 50 fels, it would weigh half of that, let's say 2 grams. This is just random weights. Let's say we've got other currencies as well. We've got, let's say, a quarter. It weighs 5 grams. So we give it all of these data. The more data we give it, the best output we expect it to give. So for example, imagine that in this machine, I am supposed to enter a coin, and the machine should understand or knows what kind of coin is that. And based on that, it gives me, for example, an output. Okay, so if I want to buy something, I should put the right currency. So it should be able to understand that this is the right currency out of the weight. If I'm putting something which is different, a currency that I didn't put as data into my machine, it is not in the data and it's a new currency, maybe the output is not going to be as precise as I want it, because it wouldn't know that this currency is such, okay? So we try to feed it with more data to be able for the machine to be able to learn, and based on that give a better output. Now there is a subset of machine learning, that is called deep learning, and this is also based on feeding the our algorithms and machines with more data, even more than machine learning. And the way it processes the input or the data, it resembles or mimics how the human brain works. So we've got neural networks in our brains that connect to each other to be able for the human brain to think. Programmers tried to mimic that and copy that by making the neural networks, and not only one set of neural networks, layers of neural networks. So the input goes through the different layers of neural networks, and it gets processed. The more layers it goes through, the better is the output. And in this case, where we require lots of data, an example is when you've got a picture, and because pictures have lots of pixels, so that's lots of data. So let's say, for example, that we feed the machine with pictures of puppies, okay, and this machine is required to understand if it sees a picture of an animal, it is able to recognize whether this is a puppy or another animal. So if we don't have lots of pictures fed into the machine of puppies, if, for example, we present it with a picture of a cat, maybe it is going to mistaken that and say that is a puppy, all right? But if we give lots and lots of data and lots of pictures for the machine, it is eventually going to detect any picture of a puppy and precisely say that this is a puppy and this is, for example, not a cat. So that's it. That's about the terms that we use in artificial intelligence.